All right, so we are to our final two lessons, which deal with one concept, which is inequalities, for our introductory unit for this year. So what we're going to talk about today are inequalities. All right, and then we'll follow that up with a little bit more inequalities, talking about how they relate to square roots and absolute values. So today, we're going to go through some very basic inequalities. All right, now one of the keys about inequalities is that you have to realize that there is an infinite amount of solutions. All right, so how do we represent that? Well, we're going to represent that with a graph on a number line. Now, eventually you may get to something, some interval notation, some other types of notation to represent that solution set. So what we're going to do today, however, is just going to graph the solution set on a number line. Now, as we look at our symbols for inequality, if there is a variable in our problem, okay, and we're considering a constant number like 3 or 8 or whatever, you read from the variable, okay? So I would read this as x is less than a. Now, notice in the second part here, the x is on the right side. I would still read this from the variable. So this is x is less than a. All right, so if it's pointing at the variable, it's indicating that that variable or that unknown or that given number is less than whatever value we have. Vice versa, if it's open to the variable, like it is here on our second bullet, I would read this as x is greater than a. Once again, notice the x is on the right hand side, but the inequality symbol is open to the x. All right, so I would still read this as x is greater than a. Now, our last two bullets just include the bar beneath our inequality symbol. Now, what that reads is so our third bullet, x is less than or equal to a. All right, so what that's going to mean is that we're going to include that initial value as part of our solution set rather than start with it, and we'll talk about how we represent that on our number line in just a second. And then finally, this is x is greater than or equal to a, x is greater than or equal to a. All right, we have that bar in there. So once again, just pay particular attention to where the variable is and the orientation of the inequality symbol to, all right, the variable. All right, so let's just jump in to some examples here and talk about how we would do this. Okay, so if we have a less than or greater than symbol, all right, so if we have less than or greater than, we're going to always put an open circle on that particular number. If we have a less than or equal to or greater than or equal to, what we're going to do is use a solid dot to represent that we're going to include that number. So if we look at our first example here, this is x is less than 2. So I'm going to find 2 on my number line. It's less than, so I'm going to put an open circle. All right, so that indicates we're going to start with 2, but we're not going to include 2. Now let's think about all the numbers that are less than 2. Those would be all numbers to the left-hand side. So what I'm going to do is just take and draw an arrow like so. So what this is telling me is if I pick any number where this arrow is pointing, it will be a solution. So if I take -4, -4 is less than 2. If I take -10, that's less than 2. If I take some number way out here over here, -1 billion, -1 billion would be less than 2. So this arrow here is representing that we just keep going to the left on the number line. Any of those numbers would be a solution. Now the other thing, and sometimes it's not obvious, is that's also including our decimals. So like, you know, -0.56838256281, whatever you want to call it. So that includes all of our numbers in here, not just the integer pieces. Okay, so now let's look at the next one. This is x is less than or equal to. So notice the only difference in our graphs, the first two, is that this would have a solid dot here at 2, which means that we're going to include that in our solution set. And then all the numbers less than 2 are still to the left. So the only difference in these two graphs is whether or not we include 2 or do not include 2 in our solution set. Okay, now moving on. This is x is greater than 2. Once again, since it's greater than, we're going to have an open circle. So we're going to start with 2 but not include it. And then once again, think about all the numbers that are greater than 2. 4, 8, 38, 956. All those numbers happen to be to the right, so we're just going to take and draw an arrow to the right. And that's going to tell us that as long as I pick any number over here, it will be a solution, which would mean it makes this true. And then once again, the only difference on our next set is that I would have a solid dot here. And then I would, oh, that arrow's kind of, you do not have to go up. You can just go to the right. A little off on my drawing there. But once again, just any number over here. And now we're also including 2. All right, so let's go through a few more to make sure we're good and you're kind of picking up on this. All right, so once again, x is less than -3. All right, so less than, it's an open circle, -3, like so. And all the numbers that are less than -3 will be to the left of -3 on the number line, so I would just shade, okay, draw my arrow to the left. All right, if I look at my next example, x is less than or equal to 4. It's less than or equal to 4, so I'm going to have a solid dot on 4, which means we're going to include that. 4 would make it true. And then all the numbers less than or equal to 4 would be to the left once again, so I'm just going to draw my arrow. All right, so any number over here. Okay, x is greater than 8. So it's greater than 8, so I'm going to start by putting an open circle on 8. Now all the numbers that are greater than 8, bigger than 8, more than 8 are to the right, so I would just draw an arrow to the right. Now once again, I am putting the arrow here, and that's important because what that's symbolizing for us is that line keeps extending forever and ever in that direction. All right, so getting a good habit, little details are important in mathematics. All right, so our a final example on the slide, x is greater than or equal to -7. Would give us a solid dot on -7. And then once again, all the numbers that are greater than -7 would be to the right. So I'm just going to take and draw my arrow. This one's a little bit better than that last one. All right, to the right-hand side. Okay, so let's go through one more slide, all right, before I let you do some on your own. Okay, and let's look at these. And what I've done now is just change the orientation a little bit, all right, to help you see how you read the problem. Okay, so now, once again, if I look at this, I'm always reading from the variable. So this is x is greater than 5. Now, if this is hard for you, you can rewrite the problem. So you can flip it so that x is always on the left. What you have to do is you have to flip everything. So notice it's pointing at the 5 and open to the x. So when I flip it, it has to have that same orientation. All right, so it's open to the x, pointing at the 5. So if you flip everything, okay, or move it around, that includes your symbol. Okay, so if this helps you to rewrite it, please do so, but be careful to maintain that same orientation of your inequality symbol. Now, let's go to greater than 5. So that's going to be an open circle on 5. All right, and then I'm going to shade to the right. Okay, now if we look at our second bullet here, okay, x is greater than 0. All right, so I'm going to go to 0. Greater than would be to the right, so I'm going to shade to the right. All right, x is greater than or equal to -1. So I'm going to go to -1, and since it's greater than or equal to, I'm going to put a solid dot, and all the numbers bigger than -1, greater than -1, are to the right. And then our final example, once again, I read from the variable, x is less than or equal to 6. Once again, if you were to rewrite that, you flip everything, notice it's pointing at the 6, open to the 6, pointing at the x, open to the 6, keep our bar in there, and we know we're going to have a solid dot since we have that equal to in there, so we're going to include this in our number set, and then all the numbers less than 6 would be to our left. All right, so I think that's enough examples for you now, so I'm going to give you 4 to do here. Okay, so you may have to just sketch your own number line real quick, all right, and go ahead and pause the video, sketch the graph for these, and we'll see how you did. All right, so let me flip to the next slide. I have the answers here for you. All right, so you can see open circle on -3 and less than is to the left. Solid circle on 7, less than is to the left. Once again, pay attention to your orientation here. Solid circle on 8 to the right. Okay, open circle on -2 and to the right. So these, all right, are the challenging ones for a lot of people because of the orientation of the x. Okay, so the final piece here today is, now let's reverse the process. What if I give you the graph? Can you write the inequality? Okay, so now when we look at this, all right, so let's worry about writing our inequality for this guy. So x, and we obviously have a 7 here, so we know there's some relationship between a number and 7. Now notice I'm getting all the numbers to the left of 7. So 0, 1, 2, 3, 4, those are all less than 7, all smaller than 7. So x definitely has to be less than 7. Now I look, it's an open circle, right? So that means we're not including 7, so there's no bar, so this would be my final answer. Okay, when I come down here, I have x and I have 0. Now once again, I can see all my numbers here are to the right. 1, 2, 3, 4, 5, 6, 7. Those are all bigger than 0. So x has to be greater than 0. And then I see, oh, we have a solid circle. So that means we want to include 0. So x can be equal to, all right, as well. So we have greater than or equal to 0. And so that would be my final answer. So let me give you a couple of these to wrap up today's lesson. All right, so here's your 2 problems. There we go. Give these a shot. Write those inequalities, and then turn the video back on, and we'll see how you did. All right, so real quick, here are the answers to those 2 guys. All right, so our first one, x is less than or equal to -3, and then x is greater than -9. All right, so that wraps up this first lesson on inequalities. So there's, I think, 5 self-assessment questions in your Google form. Try those, and then watch the next video before you move on to the homework assignment for this lesson.